My name is John Michael E. Reyes and I'm currently a second year BSIT student at Batangas State University. First of all, please bear with my voice because I'm still pretty sick, and we are here today in the chapter for the network access in order to answer all the activities here. And the first activity is the physical layer terminology. It is somewhat dragging the items into their meanings. So let's try to answer it correctly. Then the first question is media that uses pattern of microwave to represent bits. In this statement, we already see that there are keywords, the patterns of microwaves. We all know that the only thing that uses the microwave patterns are the wireless. So let's drag the wireless here. Then the capacity of a medium to carry a data. There are some confusion about the capacity of the medium of the data and the transfer of bits, somewhat about in bandwidth and throughput. And bandwidth is somewhat in data and throughput is all about bits. That's the keyword that I always use, the data and the bits. For the data, it should be bandwidth. Then media that uses pattern of light to represent bits. We all know that only fiber optics uses light to represent bits. There are two types of fiber optic, the single mode and the multimode. The multimode have more lights, I think, than a single mode, but a single mode can travel farther than a multimode. Then, as I've said earlier, a measure of transfer of bits, the keywords bits across the media, and it should be throughput. Then, media that uses electrical pulses to represent bits, and the last one should be copper. Sorry. Then, let's check. As you can see, we've successfully matched each physical layer term to its description. Then, let's proceed to this is the second activity of the chapter 4, the copper media characteristics, the UTP, STP or shielded transfer protocol or the unshielded transfer protocol, then and the coaxial copper. And let's proceed to answer them. The first question is attach just antennas to wire devices. Can be bundled with fiber optic cabling for two-way data transmission. It can be UTP because of the fiber optic cabling. We all know that UTP is the unshielded it is unshielded, and the fiber optic is somewhat shielded and has a 6 or 5 layers on it. So it's not UTP, and STP is somewhat, it can be, but still it's not. And the coaxial it is perfectly uncoaxial because of the antennas to the wireless device. Then counters EMI and RFI by using shielding techniques and special connectors. As you can see, guys, there are so many context clues or ideas in order to specify which of this statement is pertaining to. First is the EMI and the RFI. It counters EMI and RFI. We all know that the one that counters EMI and RFI are the ones that using shields, just like this shielding techniques. So we all know that it is already the STP or the shielded transfer protocol. Then the most common network media is somewhat, we all know that the UTP. Then terminates with BNC, N-type and F-type connectors. The only one that have those characteristics or types are the coaxial. And let's check. So you can see we got all correct answers. Then let's proceed to another one. And this is the third activity, the T568A cable pin out. It is somewhat the RJ45, the color. We should align the colors or the wire colors to build the TIA and TIA. Then let's proceed. And first, we all know that white white and mixed colors are always first, then green, then in the middle, the constant in this wiring is blue and the brown. That it should be alternate. Strip, not strip, strip, not strip, strip, stripe, I mean, not stripe, stripe, because, or stripe, solid, stripe, solid, stripe, solid, stripe, solid. In order to build it successfully, then let's try to check it later. Then check. As you can see, I've successfully chosen the correct T568A cable. It should be stripe, solid, stripe, solid, stripe, solid, 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 stripe, just like that. Then the difference between the T568A and the T568B is somewhat only the color. That in T568A, the green ones are on the first two lines, but in the T568B, the orange should be the first one. First, as I've said earlier, stripe, solid, stripe, solid. Let's do the pattern then. And the only constant is somewhat the blue and the brown colors. Then let's see. Stripe, solid, stripe, then solid, then stripe, then solid. Then let's check. As I said earlier, the only constant color that can't be moved are the blues and the brown. The only one that somewhat exchange is the green and the orange one. That's all. Then let's move to another. Now we're on the fourth activity of this chapter. Then the fourth activity is the fiber optic terminologies. As I've said earlier, there are two types of a fiber optic, the multi-mode and the single mode. And somewhat I've already know what are the characteristic and description of those two types. So let's answer. Can help data travel approximately 1.24 miles or 2 kilometers or 2,000 meters. It is for a fiber. It is somewhat a short distance, so it would be a multimode. Multimode are for somewhat short distance because the light rays is somewhat in a wave or something like that, and in a single mode it is just a straight line of light. Then it uses LED as a data light source transmission. Then the one that use LED is not the single mode, but it is the multimode, because LED is somewhat, it bounces back and forth then as it travels in the multimode. Then uses laser in a single stream as a data light source transmitter. As you can see in this statement, the context clues or the keyword is it uses the laser in a single stream. In that we can it is already pertaining to the single mode, because only single mode fiber optic cables are using single stream or lasers. Then used to connect long distance telephony and cable and TV application. As I've said earlier, the multi-modes are for somewhat shorter distance, and the single mode are for longer distance. Then can travel approximately 62.5 miles or 100 kilometers or 100,000 meters. As I've said, single mode is much more longer than multi-mode. Then used within a campus network. If it would be a single mode, it would be a very profitable or somewhat expensive. That's why campus networks only use multi-modes, because the radius of it wasn't in a distance or somewhat doesn't go in a 1 kilometer radius or somewhat like that. That's why it is in a multi-mode. Then let's check. As you can see, it is all correct and it's properly matched. And I think this is the last part of the activity in the chapter 4, the generic frame fields or it is somewhat inside the packet or in encapsulation or in a frame. Then let's start to answer it. And the first one is the data. The data should be in here, and the packet of the data, it is also a data, as you can see. Then the header is always in first, then in the trailer is always at the end. And in order to start the frame, we should have a frame start. Then after that, then as you can see, there are a frame stop. Then let's drag the frame stop here because it is somewhat in the end. Then in the trailer, there are description that trailer always have error detection in order to detect some errors or from in order for it to discard a packet or other things. Then let's drag the error detection here. First the address, then after the addressing, they will know the type of what packet it is or what it is. Then it would be in control, then the data would pass, then the error detection and the frame stops. Then let's check. So you can see it's all correct. Then let's go to figure number 2. Part 2 of the generic frame fields are, it contains the IP header transport layer, PDU, and data. We all know that the data is always contains the IP header, the transport layer, PDU, and the data itself. It is somewhat the best description for it. Then identifies the layer 3 protocol used by the LLC, and for that it would be the type, because that this is the discrete description of the type. Then marks the end of the frame. We all know that frame stop indicator because that there's the frame stop on it. Then identify source and destination host by MAC address. In order to identify, you need to address it. Then about the flow, it is always be in control. Then check. So you can see it is all correct, and I think that's the last part of the activity in this chapter.